Hi, Assalamualaikum and a very good morning. Now we are entering a new chapter, which is chapter 4, Introduction to Organic Chemistry. In this chapter, there are 4 subtopics altogether, which is 4.1 Molecular and Structural Formula, 4.2 Functional Group and Homologous Series, 4.3 Isomerism, and 4.4 Reaction of Organic Compound. So in this video, we're going to focus on the subtopic of 4.1 Molecular and Structural Formula first. So in this video, we're going to learn the definition of the structural formula, as well as learn to draw the structural formula in terms of the expanded, condensed, and skeletal structure based on given molecular formula. So without any further ado, let us start. So structural formula means that it is a compound that shows the formula on how the atoms in a molecule are bonded to each other. So there are 3 types of structural formula. First, we have the expanded structure, or known as the dash formula, where it shows every single covalent bond attaching from one carbon atom to another, as well as from carbon atom to hydrogen atom, as well as to another atom here. So it shows every single bonding here. Meanwhile, for condensed structure, it basically means that the bonding is being hide for carbon and hydrogen, but the carbon and oxygen bonding is still shown. All right. And for the skeletal structure is basically a bond line formula where it basically the same representation, but now using a lines here, where each single step here refers to a carbon, single intersection here refers to another carbon, here also refer to a carbon, and here also refers to the carbon. And here you can see that the hydrogen is being hide. Okay, disorotkan. And basically this structure and this structure are basically comes from the same molecular formula, which is C1, 2, 3, 4, which is C4, H9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and OH here, the last one. So you can see that with the same molecular formula, you can represent it in 3 different ways. 3, 4. 4 carbon. 1, 2, 3, 4. All right. So let us learn more about the expanded structure on how we can do that. So for the expanded structure, it basically shows all covalent bonds between atoms, and however, it is not a representation of the actual shape of the molecule. So in the expanded structure, we will always draw that in terms of 4 carbon being laid out in a 90 degrees shape. So we're going to have 1, 2, 3, 4. But as what you have learned in previous semester, it is not supposed to having this shape. Alright. However, in expanded structure, we will just follow it this way. Alright. So let's say if we have the molecular structure, a molecular formula here has to be CH3, CH, Cl, CH2, CH3. So the way that we can draw that is to be something like this. So you know that you have 1, 2, 3, 4 carbon. So you make up the carbon first. 1, 2, 3, 4 carbon. And then on the first carbon, you have 3 hydrogen. So 1, 2, 3 hydrogen. So you have settled with this one. For carbon number 2, you are attaching it with hydrogen and Cl. So hydrogen and Cl for carbon number 2, and it is connected to the previous carbon and to the next carbon, number 3 here. Alright, so we are settled. And for carbon number 3, it attached with 2 hydrogen. So hydrogen here and hydrogen here. And the carbon number 3 here is also connected with another carbon here and to another carbon here. So attached with carbon number 2 and attached to carbon number 4. Right? And for carbon number 4, it attached with 3 hydrogen. So 1, 2, and 3. Alright? And this is known as the expanded structure because you shows all the covalent bond between the atoms. Right? So 1, 2, 3, 4, and Cl here refers to the carbon number 2. Okay. Now let's say if you are given another molecular formula which is C2H5OH, you can also write it in terms of the CH3 CH2OH. Okay, so this is an alcohol, or known as the ethanol, because it has 2 carbon. Alright, so you have to draw the expanded structure in form of like this. So 2 carbon, so 1 and 2, and then you draw it 4 bonds on each carbon. It attached to 3 hydrogen, so hydrogen, hydrogen, hydrogen. This one got 2 hydrogen for carbon number 2, hydrogen, hydrogen, and then OH here. So O dash H. Alright, carbon number 1 and carbon number 2. Carbon number 1 and carbon number 2 here. Alright. So you can write it this way, and it is also represented in this form, number 1 and number 2. Alright, and for here, don't forget to put a dash line between O and H, because we have to show all the covalent bond between the atoms. So here we need to put the line between oxygen and hydrogen, which also shows a expanded structure. Now we move on into the second part, which is condensed structure. So condensed structure is basically like a reverse of the expanded structure, where it does not show single bond between carbon and hydrogen, but it shows double and triple bond. Okay, so it does not show single bond, does not. So in this case, you can see that here can be represented by CH3, here can be represented as CH2, and here you can represent it as CH3, because we don't need to show the single bond here. And all atoms that are attached to a carbon are written immediately after that carbon, like what I just did here, which is hydrogen. So I directly put hydrogen behind the carbon. So this given here as the expanded structure, and we need to do the condensed structure. And the carbon with 3 hydrogen will be written as CH3. So that's what I did just now, CH3, CH2, and CH3. Meanwhile, for this case, we will have CH3, CH2, and here we have C, O, O, H. Alright, so this is the condensed structure. And for here, you can also write it in terms of CH3, CH2, C double bond O dash OH here. Okay, because it need to show the double bond. So we can also write it this way. Moving on, for the condensed structure, we can also use the bracket here to show the heteroatom, which is other than carbon and hydrogen, or to show the functional group, alkyl group, at the side chain. So alkyl group here means the carbon change, which can be CH3, or it can be C2H5, or it can be C7H9. Okay. Now we have the expanded structure here. Now we want it to write it in terms of the condensed structure. So what we have here is CH3, and here we have CH and OH. So we can put it as CH, and the OH here we can put it out, and then the balance here will put as CH3. Okay, so CH3, CH, OH, and CH3. Meanwhile, for this part, you can see that we can put here as our main change, which is CH, and as what you can see here, CH will be attached to with the CH3 group, which is the alkyl group, with another alkyl group and another alkyl group. Alright, and therefore we can write it in terms of CH attached to CH3 with three alkyl group, because got 1, 2, and 3 here. 1, 2, and 3. Okay. Now we move on to the next part, which is the skeletal structure. So for the skeletal structure, it only shows the carbon skeleton. So the carbon chains are drawn zigzag and rings are drawn as polygon. And the carbon atom will be shown at the intersection between two lines, which is the bond, and at the end of each line. The carbon atoms are usually not shown as well as the hydrogen atom. So, however, the functional group are shown. And other atoms such as oxygen, chlorine, and nitrogen will be shown in the structure. Okay, to understand more about this, let us look into the example here. So, in order to draw the skeletal structure, we have to find the longest carbon chain first in order to make your life easier. So, in this case, we have 1, 2, 3, 4. So, this is the longest carbon chain, rantaian karbon yang paling panjang. And the carbon here will be attached to the carbon number 2. So, what we can do, we can transform the expanded structure into the skeletal structure. So in this case, I will draw the skeletal structure first. So the skeletal structure here is represented by 1, 2, 3, and 4 in the form of zigzag. And carbon number 2 will have a alkyl group or the methyl group here. So here is another carbon. And this basically, the intersection will refers to a carbon as well as the end, as well as the beginning and at the end of the line. And as mentioned, the carbon between hydrogen and carbon will not be shown. So this is the correct representation from a expanded structure into the skeletal structure. Alright, so here refers to carbon atom. Now let us look into the next example. So for the next example, you can see that carbon attached to carbon, and this carbon attached to another carbon. So you know that you're going to do a cyclic entry. So here refer to carbon, here refer to another carbon, and here refer to another carbon, but we don't have to write it. Okay, and it is attached with hydrogen, but again, we don't have to write it because it is hidden in the skeletal structure. And same goes to here and here, but we don't have to write it because it is in terms of the skeletal structure. Same goes to here. We have hydrogen, but we don't have to write it. But however, it attached to the oxygen and hydrogen. And for this case, we can write it. So we need to take another line to connect O and H. So O and H. Okay. For this thing, you need to show a line between carbon and oxygen because, as mentioned, for skeletal structure, only carbon and hydrogen are being hidden, but carbon and oxygen bond are being shown. So you will get to be something like this. So for the line here, it doesn't matter whether you pull it this way, or you can pull it straight, or you can pull it whatever you want, right? As long as you have the showing of the OH part. So you can either pull it whichever direction that you want, right? Now let's look into the last example here. So for this case, one carbon attached to nitrogen attached with two other carbons, and the end here attached with carbon here. So what I'm going to do is, this is my longest chain. So I'm going to have carbon here attached with nitrogen, carbon, and carbon. So carbon 1, carbon 2, and carbon 3. Carbon 1, carbon 2, and carbon 3. And the nitrogen is attached with another carbon. So I can pull it up or downward, it doesn't matter. And the structure will be looking something like this, because I will hide all the hydrogen atau menghilangkan semua hydrogen yang melekat dengan carbon tersebut. Okay. Right. So you can also draw it the reverse way, where for me I will start from downward, but you can also put it from above to there, and to here, because it is still give the same meaning. One carbon, another carbon here, and another carbon here, which is the same as your structure in the expanded form. All right, so that's it for the skeletal structure. Now let us look into the example that can connect all the expanded structure, condensed structure, and skeletal structure in a table. So given here is the expanded structure for this species, which is CH3, CH2, CH2, CCl, CH3, and CH3 here. So this is the condensed structure. CH3, CH2 double, CH2, and CH2. That is why it comes with to here. Carbon, carbon, Cl attached to this carbon, and then we have the CH3 and CH3 double. Alright, now we have to draw the skeletal structure. And as mentioned, in order to draw the skeletal structure, we have to find the longest carbon chain, which is 1, 2, 3, 4, and 5. Okay, and as for me, I will draw it 3, 1, 2, 3, 4, and 5. One carbon, second carbon, third carbon, fourth carbon, fifth carbon. And as what you can see here, the carbon number 4 will be attached with chlorine here and CH3 here. So it will be attaching with chlorine and CH3. But we don't have to write the CH3 because it is hidden in the skeletal structure. So we can rub it off here. Alright, so this is the skeletal structure for this species. Later, in the next chapter, you will see that the numbering here will be different. It's gonna be 1, 2, 3, 4, and 5, because the number 2 here, we will need to take the shortest number, which is the lowest number, when there is a subsequence. But for drawing, it doesn't matter. Alright, but it will matter later in the other chapters, where you have to write number 2 here instead of number 4. Okay, because we need to have the lowest number for the subsequence, for the branch untuk rangkaian di atas. Okay, now let us draw the skeletal structure. Given here is the skeletal structure, but we need to draw the expanded structure and also the condensed structure. So in order to draw the expanded structure, you basically just need to follow the shape here. So carbon, carbon, another carbon, another carbon, another carbon, another carbon, and attach with another carbon. So the shape here will be the same as this one, and the carbon number 1 here will be attached with another carbon and attached with the double bond O. Now you can ensure that you have all the double bonds between the carbon double bond, which is here, here, and here. And you have to ensure that you include the hydrogen. Okay, because each carbon atom need to be attached with 4 bonds. Okay, hydrogen, hydrogen, and hydrogen here. Right, so this is the structure of the expanded form. Or to draw it nicely, I will put it as here. Okay. Now for the condensed structure, you can write it in terms of 1, 2, 3, 4, 5, 6, which is 6 carbon, and 1, 2, 3, 4, 5, 5 hydrogen. And this is attached with COH. So you can put it as COH at the front, or you can also put it as C6H5COH. Alright, either answer will be correct. Alright, okay, I think that's all for today's video. See you again some other time. Bye.